Hello all, this is a demonstration on sample size calculation. We are using one of the online available tools by the name Statulator for this demonstration. The tool Statulator is available free of cost for our use. It provides multiple functionalities. What we are interested in currently is sample size. So we click on sample size and it opens up a page for the same. The Statulator tool allows the sample size to be calculated in different scenarios. In the earlier sessions, we understood what's the study variable, and depending upon in our operational definition of the study variable, is our study variable measured qualitatively, which means that we are dealing with proportion of our patients, let's say, of category of interest, or when a study variable is measured quantitatively. So depending upon that, there are multiple scenarios and options available. So we will have to choose what scenario best fits into our purpose. Remember that we'll need to calculate sample size separately for each of our objectives. So we'll start with simple scenarios first. So let's assume that our study variable is something which is looking at the estimating single proportion. So we go into detail and the software would ask us to feed in certain values. So first is the level of confidence that they ask. Now in the medical scientific community, 95% level of confidence is the tradition with which most of the scientists and doctors would be fine going ahead with. So we'll keep it as 0.95%. Let's assume that the study that we are interested in is the prevalence of, let's say, anemia among adolescent girls. And let's say if the expected proportion is 40%. So on this slider scale, you can change the position from left to right and indicate the desired value that you want to input. So 0.5 is 50%. So this is in fractions. So I'll make it to 0.4, which means in percentages it would be 40%. So depending on the results of the previous studies, we are expecting the expected proportion to be 40%, and hence the input value is 0.4 here. Remember earlier we mentioned that the sample size, there is no absolute number to sample size. So depending upon what margin of error we are fine going ahead with, the sample size can vary. So we say that 0.05 in percentage terms it would be 5%. So we are saying that we would be fine to go with a margin of 5% on either side of this expected proportion. So we take the margin of error at let's say 0.05. There are other options also that the software gives you, and that is all of them. You can adjust for response rate as well, and we understand that if certain portion of our population is expected to be non-responding because of any reason, we will probably go ahead meeting with a little higher number of people, so that our final sample size, the final number of people with whom we have good quality data, is meeting the sample size. So if non-response rate is expected to be, let's say, 10%, we multiply the final sample size figure with 1.11, and hence we can have 10% more people to be contacted. So at present we are not using it. So these are the three input values that we need to fit when our study variable is qualitative and we are trying to measure the proportion of something. We press calculate, and on the right side it would give us the detailed description. So the description says that assuming that 40% of the subjects in population have the factor of interest, which is anemia in this case, the study would require a sample size of 369 for estimating the expected proportion with 5% absolute precision, which means 5% on either side, and 95% confidence. So this is the entire sentence that you can write in the relevant sections in methodology, where you are describing the justification for the sample size for your respective study. In the next paragraph, they are explaining. Now you might not insert this in your methodology. This is for your own understanding. In other words, if you select a random sample of 369 from a population and determine that 40% of the subjects, which means the girls, have the factor of interest, which means anemia, which means that if you determine that 40% of adolescent girls have anemia, you would be 95% confident that between 35% to 45% of the girls in the actual population would have anemia, right? So that's how it is interpreted. This is the reference that you can cite, and it would go into in the reference list. So this was the first example. Now you might say that 369 is a little larger figure, and you might be finding it difficult to let's say collect blood samples from so many large number of study population. So you can change. So what you can change, we would prefer that 95% it's a usually scientific convention, we do not change that much. Expected proportion we should not be changing, because that we would have some basis on which we are expecting the proportion. So what we can potentially change is the margin of error. So instead of keeping the margin of error 5%, I can go on keeping it 6%, and as I change it, the number of expected sample size changes here. So I can go on increasing the margin of error till the level where I feel that studying those many number of study participants is feasible for me. So if I say that studying 93 participants is easy for me, I'll say that my margin of error is little higher. So instead of 5% on either side, now we'll say 10% on either side. So the interpretation changes. In other words, if you select a random sample of only 93 and determine that 40% subjects have factor of interest, you would be 95% confident that it would now fall not between 35% and 45%, but the range would be little longer, wider, and the range would be somewhere between 30% and 50%, right? So whenever, for all practical purposes, whether you are a student or a faculty or a seasoned researcher, the sample size calculation would always depend upon feasibility as well. So remember in the earlier discussion when we talked about balancing between scientific rigor and feasibility, we said that feasibility is also equally important. So that was the concept, and by varying the value of absolute error that we are fine going ahead with, we can change the desired sample size, right? So when you, what number that you put in your sample size in your proposal, what number do you commit in your ICMR STS proposal, is the number that you and your, under guidance of your guide, what number you feel that you will be able to do data collection, right? So if you are able to study less number of subjects, increase the margin of error, and mention your calculations, right? So this was one example of sample size calculation. We'll go with the next example as well. Now in the next example, let us assume that we are still going ahead with one group, and our study variable is measured in numbers, right? So say for example your study is about measuring the birth weight of newborns. So in that case, say for example, the level of confidence also will keep it same 0.95%, and when something is measured numerically, you your previous studies would give you two numbers. One number would be the mean birth weight, the other one number would be the standard deviation associated. So what standard deviation means is how are different birth weights of newborns varying around that mean number, right? So see for example your previous studies mention that the average or mean birth weight is 2.8 kgs and the standard deviation is say for example 400 grams. So 2800 grams is the normal birth weight and 400 grams is the standard deviation. So in this case we will enter 400 as the standard deviation, and then we have to pick up a margin of error. So how much precise do you want your estimates to be, right? So it will be in relation to the standard deviation, right? So whatever is the unit of measurement for the mean and standard deviation, same is the unit of measurements for margin of error. So I might say that I would be fine with going ahead with a margin of error of, let's say, 100 grams, and then I go on calculating. So the sample size comes up to be somewhere around 65. So what you will mention in your study proposal in the sample size justification section is, we utilize Statulator software, and assuming the expected population standard deviation to be 400 grams and employing t distribution, this is the distribution that it uses in the background for calculations, and employing t distribution to employ sample size, the study would require a sample size of 65 to estimate the mean with 95% confidence and a precision of 100. Right? In other words, if you select, this is for our understanding, this is not to be reported in the protocol. If you select a random sample of 65 from a population and determine the mean to be, say, y, you would be 95% confident that the mean in the population lies somewhere between y minus 100 and y plus 100. Right? So y might be anything. So say, for example, our study finds out that the mean birth weight was 2,900 grams or 2,900 grams. So y minus 100 and y plus 100, which means that you subtract 100 from 2,900 and add 100 to 2,900, which means that the range of birth weight would be anywhere between 2,800 to 3,000 grams. Right? So this was if a study variable is measured on a quantitative scale and we are dealing with numbers, we will be required to input the standard deviations and the precision or margin of error. What final count that you go ahead with is the final count that you find feasible. It's just that you are reporting your margin of error when you calculate the sample size. So this was demonstration. It took examples of simpler studies where you are dealing with single groups. Thank you.